Hey guys, so you see the title of the notes, Relations and Functions. It's definitely continuing on with the previous lesson, adding to it. In the previous lesson it was like using graphs to relate to quantities. Again, think of the word relate to quantities. So the two quantities are related, like time and height or whatever, if you think back to some of the graphs we did. Anyhow, you see the word relations here, so again, relating to functions, they have a relationship, so you see that word is related. And anyhow, and then functions, and so we start talking about functions in this lesson. So I have the question here, what does it mean to be a function? Here I'm advising you that relations are just a set of input and output values. Here are 4 ways to show relations. Ordered pairs, right? You parentheses with 2 numbers. The first number is x, the second number is y, right? First number is x, second number is y. So the reason they're called ordered pairs is as it says here, because they are in alphabetical order, okay? So if we're talking about ordered pairs, again, there's a reason they're called ordered. They are in alphabetical order. You can use a table for all your x and y values, right? So again, different ways to show a relation, represent a relation. Ordered pairs, a table, a graph. Notice that it's the same numbers, -2, 2, -2, -2, 0, 1. It's the same numbers, just presented a little differently. Here the numbers are graphed. -2, 2, -2, -2, 0, 1, and then 3, 1. They're represented as graphed points. And then the mapping diagram. The mapping diagram uses 2 boxes, let's say, for an box. 1 box for all the inputs, 1 box for all the outputs, and then instead of repeating any inputs or outputs, they use arrows to point at the numbers that go together. So like instead of putting -2 twice over here, they put -2 once, but they put arrows at the numbers that also pair up with -2. So like -2, -2 goes together, -2, +2 goes together, 0, 1 goes together, and then 3, 1 goes together. So you see whether it's in the input or output, instead of listing it twice, we just use arrows to point at it twice if it shows up twice. So 4 ways to represent a relation. And moving along, the domain, one of your vocab words, one of your skills or concepts, being able to identify the domain. The domain is all the inputs or x values, so the domain would be -2, 0, 3, and 3. The range is all the outputs or y values. So the range would be 2, -2, 1, and, well, you don't have to say 1 twice, but 2, -2, and 1. And as it says here, when writing the domain and range, do not repeat values. No need to write the repeats. Just if a number is included in the domain, it's included. You only need to put it once. So let's see. Given the relation, so you have your relation here. It looks like the same one from up there. Identify the domain. Select all the x values or inputs. Don't list repeats. So the domain is, remember, it's all the x values. No need to list the repeats. So we can put d equals -2, right? D for domain, -2. Don't need to put -2 again. 0 and 3, and that's your domain. Your range, you can put r equals, same thing. You can use brackets or something else if you like. Your range is 2, -2, 1, and 1 shows up, right? These are your range is your y values, right? The second number, remember it's x then y, so 2, -2, 1, and you don't need to list 1 twice, you just need to put it once. Right? If 1's part of the range, it's part of the range. It doesn't matter if you list it again. In fact, don't need to list it again. So right here, I define a function. A function is a relation in which each input has one specific output. Okay, so we'll see what that means in the next couple problems. So let's see. Given the relation 2, -6, 1, 4, 2, 4, 0, 0, 1, -6, and 3, 0, is the relation a function and why? So here's how we're going to check if it's a function. We're going to look at each x value and see what the output is. Here's a 2, -6. Here's a 1, 4. Oh look, there's another 2, but the output is 4. This is not a function. basically what a function would have is anytime 2 shows up, the same output should show up, otherwise it's not a function. So if 2 goes in and out comes -6, when 2 goes in here, out should come -6 if it's a function. So since it's a different number, again, see the input 2. If the input 2 doesn't always give the same output, it's not a function. So each input would have to have one specific y output. Since the same input has a different y output, this is not a function, and I don't even need to look at the rest of those to decide. Let's say not a function, because input 2, right, when input equals 2, there's 2 different outputs. Right, those are -6 and 4. Right, so that's what makes a function, you guys. What makes a function is each input has to have a specific output. If it ever has more than one, if any one input ever has more than one output, it's not a function. So there's that. This one's not a function. The domain 2, 1, 2, don't need to list that twice. 0, 1, 3. So 2 and 1 both show up twice. We don't need to list those. You could just use regular brackets also. 2, 1, 0, and 3. You don't need to list 2 twice, and you don't need to list 1 twice. Your range are -6, 4, 4 again, 0, -6, 0. So -6, 4, and 0 all show up twice. You only need to list them once when you write your domain and range. Okay, so same request here. Let's see, 3, 4, 7, 2, 0, -1, -2, 2, -5, 0, 3, 3. We have a problem here. This is not a function, guys. It's here because look at, when the input is 3, the output would always be the same if it was a function. So input 3, output 4, and over here input 3, output 3. Since the input 3 has 2 different outputs, this is not a function. So not a function. Input or x value of 3, right? Input 3 has 2 different outputs. That's why it's not a function. The domain, we can state the domain. Domain is 3, 7, 0, -2, -5. 3, 7, 0, -2, -5. Again, we need to list 3 twice. The range is 4, 2, -1. 2 shows up again, 0, 3. So 4, 2, -1, 0, 3. 4, 2, 1, 0, 3. Next is the relational function. Let's see. 4, 1, 5, 2, 8, 2, 9, 8. Well, none of the x values show up twice, so I don't need to worry about the same thing I worried about in the last one. Each input does have one unique output. Also, this one does give me a chance to point out if a 5 goes in and a 2 always comes out, and if an 8 goes in and a 2 always comes out, that's actually okay. As long as every time 5 goes in, 2 comes out, and every time 8 goes in, 2 comes out, that actually is okay. So what I'm saying is a function can have y values that repeat. As long as the x values don't show up twice and have a different output, that's okay. The y values can be the same even though they have a different input to match up with them. So this is a function, yes. Each input has one unique y. So each input has one unique output. The domain, remember the domain is x, 4, 5, 8, 9. 4, 5, 8, 9. The range, 1, 2, 2, 8, so you don't need to list 2 twice. 1, 2, 8, stop. Now some mapping diagrams, you guys. Mapping diagrams, see, basically, you make 2 ovals or 2 boxes and you list all the numbers in the inputs or domain, all the numbers in the range. You don't list any twice. If any of them get used twice, you use arrows to indicate that. So all the domain, let's say, I'll call that X, and all the range, I'll call that Y. Doesn't matter what kind of shape, a box or an oval or these weird things I did, but either way, my range values are 2, 1, 2 shows up again, 0, 1 shows up again, and 3. Alright, so those are all the different numbers in the domain. My range, my output, -6, 4, 4, 0, -6, 0. So same numbers, show up a couple times. Well, 0 is one of them, -6 is another, and 4. Now instead of listing numbers twice, I'm using arrows. 2 matches up to -6, so arrow. 1 matches up to 4, so arrow there. 2 matches up to 4 also. Okay. 0 matches up to 0. 1 goes with -6. And 3 goes with 0. So the arrows do get a little sloppy, but again, you don't need to list any numbers twice. You just might point at those numbers twice. So moving right along to the next one. Again, same thing. Just going to use a mapping to represent this relationship, X and Y. 3, 7, 0, -2, -5, 3. So 3, 7, 0, -2, -5, and you don't need to list 3 twice. Your Y's, your outputs, your range, 4, 2, -1, 2, 4, 2, -1, 0, 3, 0, 3. You don't need to list 2, right? You don't need to list 2 twice. So 3, 4, arrow. 7, 2, use an arrow. 0, -1, use an arrow there. -2, 2, so arrow. Notice how 2 arrows can point at one number. -5, 0, there's that. And 3, 3, so from 3 down to 3 there. So there's the mapping for that one. Oh, dang it, my bad, you guys. There it is. So you can take a look at that. All I did is draw arrows again from 3 to 4, 7 to 2, and kind of so on. Okay, so make a mapping is one of the instructions. So another mapping. Really the only difference on this one is it asks me if it's a function also. So I can make a mapping, but I can also tell whether or not it's a function by looking at this -2, 0.5, 0, 2.5, 4, 6.5, 5, 2.5. So it looks like each input does have one unique output. That's because none of the inputs even repeat. If an input were to repeat, then I could really check if it's a function. But since I only have inputs that are different, it's for sure a function. -2, 0, 4, and 5, -2, 0, 4, and 5, and my outputs 0.5, 2.5, 6.5, 2.5. So 0.5, 2.5, and 6.5. -2 goes with 0.5. 0 goes with 2.5. 4 goes with 6.5, and then 5 goes with 2.5. Once again, though, as long as each of these inputs, like as long as every time -2 shows up, 0.5 comes out, and every time 0 shows up, 2.5 comes out, every time 4 shows up, 6.5 comes out, and every time 5 comes up, 2.5 comes out, this is a function. So since we only have those numbers, yes, it's a function. Right? Each input has one unique output, and then this last one, X and Y, map it out. 6, 4, 6, 5, so 6, 4, and 5, and then 5, 3, 4, 8. Outputs 5, 3, 4, and 8. 6 goes to 5, 4 goes to 3, 6 goes to 4, and 5 goes to 8. So there's the mapping, and is it a function? Let's see. If 6 goes in and 5 comes out, 4 goes in and 3 comes out, 6 goes in. Oh, there's my problem, guys. If 6 goes in, it always has to have the same output. So since 6 has 2 different outputs, no, not a function, right? right? The input 6 would always have to have the same output if it were a function.